Hi everyone! Today I'd like to start with a question. What's the fastest engine you've ever seen? Maybe it was a car engine with a turbo, or a street bike, or some kind of plane. But what if I told you there was something faster? A new discovery has been made, the rotating detonation engine, or RDE for short. Today I'm going to be explaining this new engine. The research for this discovery was conducted by scientists and engineers at university, government labs, and aerospace companies around the world, including notable contributions from Raytheon Technologies and the U.S. Air Force Research Laboratory. To better understand why RDEs are being hailed as a breakthrough in propulsion technology, let's start by exploring how these engines function. So let's start with the question. What is this engine and how does it work? Well, RDEs use a spinning detonation wave to generate thrust. Fuel and oxidizer are injected into a circular chamber where a continuous ring of explosions or detonations travel at supersonic speeds. So, I have a drawing here, example 1 right here, and it shows combustion. So this picture shows how combustion occurs in the ring-shaped chamber. So in real life, this would be a solid piece, and this right here, the orange pieces, would would represent the combustion that occurs inside of the circular piece. Then in these two, I have example 2 and example 3. In example 2, this picture shows how fast-moving air is taken into the chamber and the mix of fuel is injected. So this is the fast-moving air and the mix of fuel is injected in the middle. And then we move to example 3, and that's going to start the detonation or some of the combustion and like the explosions. So moving to example 3, this final picture shows the detonation that occurs after the mixture is added. It moves in a wave that circles around the ring as long as fuel is mixed. So with this orange arrow, you can see that it moves around this way. And with the orange squiggles on the bottom, you can see that's where it begins, and the blue is supposed to represent the flame. But we can further break down and define a rotating detonation engine in this context. Rotation means to spin around. Detonation means rapid explosions, not just burning. And finally, an engine means a machine with moving parts, and it converts its power into motion. When it's all put together, a rotating detonation engine is a machine that converts rapid explosions that are constantly spinning around into motion. This process produces powerful shock waves and high efficiency. The detonations rapidly combust the fuel-air mixture, creating intense energy and pushing exhaust out for maximum thrust. In a closer look, the fuel and air are mixed and injected into the chamber. The detonation wave ignites the mixture, creating powerful shock waves. This process produces thrust more rapidly than a traditional flame. With a better understanding of what this engine is and how it works, let's now take a look at how RDEs compare to the traditional jet or plane engine. RDEs use detonations instead of deflagrations or steady burning. Traditional engines rely on continuous steady flame, while RDEs harness supersonic shock waves for combustion. Another big difference is that traditional jet engines do not release as much energy or power as RDEs. Detonation engines release more energy faster because of the way the fuel-air mixture burns. In a detonation, the combustion happens almost instantly in a powerful shock wave that moves at supersonic speed. Whereas in a traditional engine, the front flame moves much more slowly at supersonic speed, gradually burning the fuel-air mixture over time. Another difference is that RDEs have fewer moving parts and a simpler design. The rotating detonation concept reduces mechanical complexity, potentially improving reliability and lowering maintenance. With fewer parts, it may mean less of a chance for multiple breakdown and less costly maintenance. Also, with less wasted energy, reduced weight, and a quicker response to controls, it can all contribute to a better overall engine performance. This efficiency and simplicity can help the engine deliver more thrust and power, which can translate to faster and more reliable flights. So, what do these innovations and differences actually offer in terms of real world advantages? Let's look at the potential benefits and impacts of RDE technology. RDEs promise greater fuel efficiency and higher thrust. Studies show RDEs can deliver more power while consuming less fuel, which could lower cost and emissions. RDE research encourages new approaches to engine design and pushes the boundaries of what's possible in propulsion. As technology matures, it could set a new benchmark for engine performance in both commercial and military aviation. Ongoing research and development are bringing practical applications closer. Collaboration between industry and academia is accelerating process, with potential uses in future aircraft, rockets, and even space exploration vehicles. With all this work and research, RDEs could make supersonic and hypersonic travel more practical and accessible. Also, for future explorations of space, RDEs could be used, and they could boost the efficiency of missions. Now that we've explored what RDEs, or rotating detonation engines, are all about and how they can shape the future, let me wrap things up and share why this technology is just so exciting. Today, we explored the groundbreaking potential of rotating detonation engines and their role in the future of aviation and aerospace. Even if it was a lot, we talked about three major points. Number one, what are RDEs and how do they work? Which is they are continuous spinning detonation to generate thrust, a process fundamentally different from traditional engines. Number two, how do RDEs compare to traditional jet engines? Unlike regular engines, RDEs rely on supersonic shock waves and have fewer moving parts, making them simpler and potentially more reliable. And number three, how can these engines help the future? These engines promise higher efficiency, more power, and could lead to significant advancements in air and space travel. As G and other co-researchers wrote in 2020 in the International Journal of Aerospace Engineering, the RDE-based engine exhibited clear advantages in both efficiency and power output, indicating its great promise for the next generation of propulsion systems, which is from the article uh, Comprehensive Performance Analysis for the Rotating Detonation Based Turboshaft Engine. As research and innovation continues, rotating detonation engines may soon transform how we think about propulsion, setting the stage for a new era in aviation and space exploration. I hope everyone got to learn something new today, because I definitely got to. If there's any questions, please feel free to ask. And I hope everyone got to enjoy listening, and I hope everyone has a great day. Thank you so much. Bye.